and we'll discuss how Instagram, serves you reels so fast, right? In all the cases, consistent hashing is able to handle those kind of scaling and downscaling and upscaling things with minimal disruption in the application and without disturbing the UX. Okay, these videos will reside like this. Okay. Hey everyone, welcome back to the channel. So in this video, we are going to discuss the system design behind Instagram Reels. And we'll discuss how Instagram, serves you Reels so fast, right? You just keep on scrolling and it just, seamlessly displays Reels for you without any lag, without any slowness as such, right? So let's just discuss how does it do that. So before that, I'll suggest you to go through this video where I've discussed about CDNs, okay? Because CDNs is a crucial part of distributing content so fast. So if I first watch this video, so in CDNs we have a central server here, okay? And we have edge servers like this, okay? In different physical locations we have edge server. This A server may not be the single server. Again, there will be multiple distributed servers here. It's not a single server. Here also there will be multiple distributed servers. In brief, what does this A server do? Those A servers basically cache the data, right? If let's say someone uploads an Instagram video here in the central server, that video is cached in these A servers so that they can be served to the user in a quite seamless and fast manner. Okay. So in today's video, we are going to discuss how inside this A server a very important system design algorithm called consistent hashing is used to serve you content in a complete seamless manner without any breakdown, without any lag or without any hiccups. Okay. So before discussing about consistent hashing, first we'll discuss about the normal hashing first. Okay. I mean, how does normal hashing works in terms of a distributed system? Let's say we have this we have some videos like this. Okay, so these are the reels. Okay, let's assume like this. These are the reels object in the database, okay, which the users have uploaded. Okay, let me just color it with some different colors so that it will be useful to identify later in the explanation. Okay, let me just do it quickly. So these are our videos. All right, now how does a normal hashing works is we will have a hashing function here. Okay, this is a hashing function that we will have. What does this hash function will do? It will take the object IDs. Okay, each of these objects, video objects, will have its object ID, right? Some kind of identifier, like we have incremental ID in SQL, some Mongo ID in Mongo objects. So this will have its own ID. So using that object key or object ID, what we will do? We'll pass this to a hash functions, right? Each of this object key will be passed to the hash function. It will spit out a hash values for us within a hash space. Now, what does a hash space mean? Hash space is nothing but a list of range or range of numbers like this. Let's do, we have a range of numbers like this. So this is, let's say, x0, this is, let's say, x1, and similarly we have x1. So this is our hash space. And once the object keys are passed into this hash function, it generates a hash value from this hash space. Okay. Now, once the hash values are generated, what we will do? We will divide it with a value called n. So this hash value that it has generated, we will divide it, or we'll get the modulo n, where n is nothing but the number of servers that we have, or number of distributed, let's say, cache servers, right? Or database server, cache server. It can be anything, any distributed server. So in our context, it's a, let's say, distributed cache servers. So let's say we have 3 servers like this with us. Now, once the hash values are generated, we are dividing it, let's say, number of edge server. In our case, it's 3. So we'll get the modulo 3 of that hash value. So it will generate a number between 0, 1 and 2, which will determine which server the values or the object will be cached in, right? So let's say after the hashing was done, we identified that these videos will reside like this, okay, in an even manner. Now this is fine. There is no issue with this entire normal hashing technique until and unless we have the number of servers as fixed, until and unless we are sure that none of our servers will fail ever. But that is not the case in a real life scenario, right? So systems can fail, the servers can fail, or the network connectivity between the user and the servers can fail, right? Or the server may become unresponsive. So during those time, what will happen if one of the server fails, or let's say we add one more node into the distributed architecture to handle more load? So in both the cases, The issue with this normal hashing is very, I mean, it's vast, okay? Because let's assume the server was dead, okay? This was dead. The server, so somehow the connectivity between the user and the server become unavailable. Now what we will have to do, now the number of available servers changed, right? It became 2. That means for all the objects, all these objects, the hash value has to be recalculated, and all these videos will be redistributed among these 2 servers. Okay, so what does it do? It will involve a lot of to and fro and lot of rebalancing and the movement of data movement across servers, which is not only time consuming, and in that period your application will become very unresponsive. It will not work properly. Again, these 2 servers will itself become unavailable, or become unresponsive very fast, because they are involved in exchanging or managing the data transferring, right? So this approach becomes very costly for us. Okay, with this, even if let's say we are adding one more server to our distributed architecture, in that case also the n value changed from 3 to it has become 4. Again you have to calculate hash value. Basically you have to rehash your entire object storage, or you have to calculate the hash value for each of your objects again, and distribute the loads evenly across all the nodes. Okay, so in order to handle this issue, we have a very important system design algorithm called consistent hashing. Now in consistent hashing, what do we do? We have this hash space. Okay, hash space is nothing but a range of numbers that this hash function can generate, and a good hash function will generate hash values which will be uniformly distributed across this space. Okay, now in consistent hashing, we'll get rid of this thing first. We won't perform this modulo operation anymore. Okay, this modulo operation that we are doing here, or we won't do that, will directly act on the hash value that has been generated. So what we'll do now, we will take this hash space, okay, then join this together. Okay, basically we'll join these two and together to form a ring or circle. Just think it like you folded an entire hash space like this and formed a ring. Okay, so in this case what will happen, we have a hash ring now. Okay, or consistent hash ring we have. Let me just so we are representing this hash space in terms of a circular hash ring. Cool. Now what does this hash ring do? In this hash ring, we'll not only calculate the hash value of these objects, along with that we'll calculate the hash values of these servers also. Each of these servers has their own IP address. So we'll calculate the hash value of each of these server, and along with the object keys, and place them on the ring. For example, let's say we calculated the hash values of our server A, and it turned out to be, let's say, x3 or x5 or some number. Okay, let's say 2005. So what will happen, we will place it. Now what we'll do, we calculated the hash value of this server or server's IP using the same hash function. We calculated hash value and we place it here, let's say. Okay, similarly we calculate all the hash value, okay, for all our other 4 servers that are available, and we place them on the ring like this. Similarly, using the same hash function, what we'll do, we'll calculate the hash value for these objects also. Like this, we calculate the hash value for this all of these objects, and we'll place them in the hash ring. How do we place these objects in the hash ring? First of all, we have to think that as soon as a user comes and uploads a Instagram video or Instagram reel, what we'll do, we'll first upload that in the main storage, just like we saw here, right? We'll upload it in the main storage, and then when we'll be distributing it across the edge server or caching it across the edge server, what we'll do, we'll first calculate its hash value. Then in the hash space or in the hash ring, we'll see which object is the nearest available server. Okay, because we have already hashed our servers, right? We have already hashed our servers and placed them in the hash ring. So we'll move in a clockwise direction in this ring, and then we'll find out which server is the nearest location available for this server. Then what we'll do, we'll then just physically place that video or cache that video on that server. So that's how actually that caching is done, because you won't have servers in a circular manner, obviously, right? In physical location, they will be placed across different regions. But conceptually, first you will calculate the nearest available server for this object, and finally physically you will just place that on that physical server, right? Now when a user comes and watches reels, and let's say he just scrolls on this reels, and he just, let's say, request for this green reel, right, or green video. What our application will do, it will then pass its object key to the hash function. It will find out the nearest available server, okay, in that hash ring. Then query the IP address. It will send a request, and using the IP address of this server, because we will be storing metadata also along with each of these nodes in this hash space, we'll query that particular server using its IP address and access the content from that server. So that's how this hash ring works. Now, how does it deal with the two problems that we saw in a normal hashing? Let's say one of the node becomes unavailable, it fails. Let's say it failed, okay? For some reason it failed. It is not a part of the ring anymore. Now what we have to do is just simply have to move these two objects only, because earlier this blue and green objects were a part of this server, right? Now this became unavailable. Now what you have to do, you have to only move these two things or two objects to this, right? So we'll only move these two objects to that server, okay? As you can see, unlike the normal casing where we had to recalculate the hash values again, then we had to again transfer the entire set of objects or all the objects across multiple servers. We don't need to do that here in the consistent hash. Similarly, if we have, let's say, instead of removing, we are adding, let's say, one more server, okay, in this, somewhere around this. If I just add one more server somewhere around this, let's say the load increased and I added a new server and I calculated its IP address, and I got it IP address and calculated the hash value using the hash function. I place it here in the ring. So in this case, what I have to do, I only have to move this object, because this object earlier was a part of this server, right, or this cache server. Now I have to move it to this server. So the data transfer, the amount of data transfer across servers been reduced by a lot, right? So that's what the benefit of consistent hashing is, using this hash ring concept. But consistent hashing also comes with one problem, okay? The problem is, what if when we are generating the hash values for our servers and placing it in the ring, what if they're, largely skewed as in, let's say, all of our, let's say, A servers are like this, okay? That means, and let's say we have a lot of videos which are falling in this portion. So here, if you can see, this server is overloaded, right? Because all of these videos, when you are moving in a clockwise direction, all of these videos will be stored in this server, whereas this server has no load at all, right? So this uneven distribution makes it worse. Let's say this is our server 1, this is our server 2, this is our server 3. So uneven load distribution becomes a crucial issue in consistent hashing or circular hashing concept. In order to tackle this problem, what we will do, we will introduce a concept of virtual servers, okay? We'll create virtual servers like this, okay? And we'll place them randomly. We may create, let's say, 3 copies of virtual server V1 as virtual server S1, okay? And we can place them across the ring wherever we want. Let's say we have created 2 copies of it, and this is, let's say, S1 underscore V1. Then we are creating, let's say, one more copy of this, and S3 is, let's say, placed here, and this is, let's say, S3 V1. So like this, what we are doing, we are creating virtual copies of the servers, right? Let me just move these things. So in this way, what will happen? Now what we are doing, we have virtual copies, right? We have virtual copies of the server in the hash ring. Now, using the same concepts of hashing and hashing the server IP and object keys, now we'll be distributing the load across multiple servers. Now when we will be calculating the corresponding server for these objects, right? These objects, you will find that, yeah, these videos has to be stored in S1. So you'll go and actually, let's say this is S1. So you will actually store this in the S1 server, because the address is S1V1, but this is the virtual address. We don't have a physical address like S1V1 as such. So you will utilize S1 for this S1V1. So finally that object will stay here, okay? Similarly, and let's say this object, right? Earlier when S3 was not there, all of the video were going to S1 only, right? But now as soon as we introduce some concept of virtual server here, now this object, this pink object that you see here, that is now a part of S3. Let's say this is S3, right? Server 3. So that's how we introduce the concept of virtualization in the hash ring to do even load balancing or load distribution. And now more the number of the virtualized server in your hash ring, the more will be the even load distribution across multiple physical nodes, okay? But how many virtual servers you should have. That depends on your application structure and your query and your architecture plan. You can have 2 to or 10 or 20 virtualization per node, right? Per server you can have 20 virtualization nodes across the circular hash space. But there is a trade-off definitely, because you will be storing the metadata, right, for each of these virtual server, because all of these virtual servers finally target to this single physical server. So it will definitely take a lot of space from your hash space definitely, and you have to store the metadata repeatedly and redundantly in your hash space. So that's up to you. That's a trade-off you have to do definitely in order to accommodate for the even load distribution and have fault tolerance in your architecture. So you understood today, when someone comes and uploads his reels in this central server, that video is sent for caching to this S server, and inside this S server, let's say this is a distributed S server, okay? So this is a distributed S server of this. Let's say this purple color server is actually a cluster of some distributed cache servers like this. The videos are actually cached in this distributed cache server using the concept of consistent hashing, okay? And that's how you get to access the reels in a smooth and fast manner without any lag, and in a seamless manner you're able to access the reels on Instagram. So consistent hashing is a quite important concept in all of your content delivery network platforms. Almost all the content delivery platforms use this consistent hashing for minimal disruption when there is, let's say, server failure or they are scaling up the application. In all the cases, consistent hashing is able to handle those kind of scaling and downscaling and upscaling things with minimal disruption in the application and without disturbing the UX. Okay, so if you understood about the concept that we discussed in this video, that's the consistent hashing, which is one of the important system design algorithm that you need to learn. Let's target for 40 likes for this video. Okay, and if you like my content and like this video, please consider subscribing to my channel. I create this kind of real life use cases based on system designs. You can check out my playlist on system design use cases and basic concepts. You can click on the eye icon to explore those. So you'll definitely find them interesting and resourceful. So if you have any doubts about whatever we discussed in this video, put them in the comment section. I'll be definitely answer them. So thank you for watching this video, and I'll see you in the next one. Thank you.